Hello, welcome everybody. You should have just corrected your skills practice worksheet from the other day. I'm showing it here to you again in case if anybody was absent so that they do have the answers. Feel free to freeze this and check on your own, but you should have done this in class already. Your new lesson. Here you go. Take out your notes and away we fly. 4-3 Congruent Triangles. So I'm going to start with just kind of revealing to you what the definition of a congruent polygon is. Now, just talking about the word polygon for a moment here. Polygon is basically any enclosed shape. So it could include squares, it could include rectangles, it could include pentagons, it could include triangles. But we're going to be specifically talking about triangles, but the first definition about this congruency is about any polygon, not just triangles, but we'll be focusing in on triangles. So this is kind of an important slide which leads to the entire lesson. What are the important pieces here? Well, let me kind of underline them so that you can see the important parts. So when you have two triangles, I have triangle ABC over here and triangle KHJ. Those triangles are congruent. If I were to cut one out, place it on top of the other one, maybe rotate it around a little bit, but they are identical in shape and size. So when you so the words here are as if two polygons are congruent if and only if their corresponding parts are congruent. So parts of a triangle, for example, are sides and angles. So here is your listing of angles. All of these pairs of angles are congruent, and they're done in different colors to illustrate that. Notice how this triangle here, the second one, if I wanted to actually make it fit exactly on top of the other one, I would kind of have to turn it a little bit. So that's why this A is in red here, which is a lower left corner, but this H here is in the upper right-hand corner. So, it is a little different sometimes. You can't just look at them and they won't be lined up exactly. So then just kind of taking a look at the B and the C and how those correspond to both the J and the K respectively. The sides, don't forget to name a side of a polygon. You would then need, let me go to my lightsaber here. You would then need this side here, and since that side is between the red and the green angles, then the red and the green angles here would be its corresponding side. So corresponding marks, we've only done these one little marks in the past, but now if you have this side here, which is the same as this side here, but it happens to be longer than the one mark side, we just dictate that through a double mark. And then the triple mark and the triple mark would be same lengths. And here are your congruent statements for those sides. With your angle measures, we've talked about these arcs being congruent. And then what happens if this was congruent to this side, but it's a different arc length, or a different arc measurement than this one, so then you could put 2 or 3 lines through them like you have here. Now the congruent statement is the final statement, and that just says triangle ABC is congruent to triangle HJK. Mistakes students make is they'll write the second statement is triangle KJH or some different order. Since the red one is first here, the red one or its corresponding part must be first there. Likewise for the other pieces. The third angle theorem comes next, and that basically just says if two angles in one triangle are congruent to two angles of a second triangle, the third angles have to be congruent. So if I know these two right here in this problem, like C is congruent to K, and then B is congruent to J, this last angle has to be congruent also, just due to the fact that all angles in a triangle must add up to 180. So if you did the math, it certainly must work out. Now here's example 1. So there's a lot of writing here, but what I'd like you to do for example 1 is draw the picture. So if you need to pause the video, please pause the video. Try to get this exactly right so that you guys have the exact picture with the, now this is a polygon, so there's a four-sided figure. We call those quadrilaterals. But try to draw a quadrilateral RQPS and then the other one below it. Now, it doesn't really have to matter that they're exact same size, but feel free to pause and make sure that they look similar, but your idea is to make them perfect, but it's hard sometimes when you make a sketch. Now, the question, let's read through this top part. Show the polygons are congruent by identifying the corresponding parts, then write congruent statements. Because this was the given picture, this is the answer for corresponding parts. So I'll just focus in on one of these at a time, and then I'll let you kind of figure out the rest. Since this has one angle mark P, I look for its corresponding part, the one angle congruent mark G, so that's why P is linked with G. Likewise for the rest of those. I think it makes pretty easy sense to you. And then if I was going to talk about this side QP, and let's say it had a length of like 5 centimeters, since this also has the one marking with it, this also would have a length of 5 centimeters. Now I don't know it's 5 because I didn't have the numbers in there, but you kind of understand that those parts are the same. Now, the last thing is to write a congruent statement. These are congruent statements for the angles, these are congruent statements for the sides, and since all the corresponding parts of the two polygons are congruent, then you could write this final congruent statement. This is a congruent statement about the entire polygon. And once again, feel free to pause if I'm going a little too fast. Now, I'm going to check your progress, so I'm going to have you draw these two figures, which appear to be trapezoids, and we'll talk about that later in the year also. But I'd like you to do your congruent statements just like you did on the last one. Please pause the video and attempt to do so. Okay, doing this really quickly, I'm going to have angle A is congruent to one mark over here, angle W. And then angle B is congruent to angle X, and then angle C is congruent to the 3 marked one, which would be angle Y, and then angle Z is congruent to the 4 marked angle, D. I probably should have put the D first since that's the pattern I was using, and then the Z second. Those are the sides, and then likewise, I'm not going to do all, or those are the angles. Likewise, I'm going to do the sides, but I'm not going to do all the sides, but I'll just do a couple. So I'm going to start with just this one in red, which is side BC. Since we're talking about congruent, you can't leave off the segment bar. If it was an equal, you could leave it off because that means distance. So that is a 1 marking 1, so this is a 1 marking 1. I would also like to get you in the habit of writing it correctly, and that would be XY, not YX. If the B comes first, that's the double mark, then you should start with the double mark X. And the triple mark angle for C is here, and the triple mark in this figure is Y, so that comes second. I'll do one more, so you get the hang of this. So another side could be, I'll make a little wiggly line here. I'm going to do this side. I'll change colors to this one. So I'm going to do CD. So I just picked a random side, CD. Now I have to be very careful when I write its buddy. The C happens to have 3 congruent angle marks, so I need to find its buddy. Its buddy is Y, so C goes with Y. And then D goes with Z, because that happens to be like the 4 marks. It's hard because I kind of covered it up with the line, but you see the 4 marks here, so YZ. You would have to do the other 2 sides, but for lack of time I'm going to eliminate those. But my final statement is going to be polygon, and I'm going to go alphabetical to start with. It doesn't matter. A, B, C, D is congruent to, I ran out of room, so I'll go down here, polygon. Now A was the 1 mark, so I got to start with W. B was the 2 mark, I got to move to X. C was the 3 mark, I got to move to Y. And D was the 4 mark, I've got to finish with Z. So it's hard to see that, and a lot of you get freaked out by that, so I'll write it a little clearer here. W, X, Y, Z. So when you write congruent statements, one of the pieces is angles, one of the pieces is your listing of sides, and one of your pieces is the complete, utter whole polygon or whole shape. One more, so this is 1B, and I'll just do a couple different ones because these don't have marks on here. So I'll start with just an angle. So angle L is congruent to angle, oh, where's the other 51? Here it is, Q. And I would likewise continue those. Then when I do the sides, I would do like LK is congruent to its buddy. Where's the other 40? Right there. So now it's either QM or MQ. I'd like to keep things straight, so I'm just going to write an MQ and check my work and see if I'm right. The L was 50, so the M better be 50. Let's check. Oop, I screwed up. So it's actually QM. So since the L was 50, the Q has to be 50, and then the K was 78, so the M better match with 78. And then wrapping it up with the triangles, I would say triangle, pick any order to start with, LKJ is congruent to, now this choice has got to be important. L is 50, so I've got to have its 50 buddy. So triangle Q, then the K is 78, so the 78 is M, and then obviously the last one is P. All right, moving on. Now here, this is example 2. So I'm going to give you a moment to write example 2 down, freeze the video if I'm going too fast, and then draw the picture. So there's a couple things that we're going to do on this one. First of all, reading the question, it says find the values of x and y. But how do you know what the values of x and y are unless you have a congruent statement? Which I do. So I've got some things that are going to lead into proofs here because we're going to come back to proofs, but let's just kind of reveal them step by step. I think I'm going to have to delete all those circles. All right, so the first thing is that since these triangles are the same, ABC and DEF, I know that F and B are the same. Why? Well, first of all, the F lies in the middle location, so the middle location is its buddy. The middle location being the 3-letter system, the letter in the middle. So I wrote here CPCTC. This is a shortcut for corresponding parts of congruent triangles are congruent. Since these are congruent triangles, all of their corresponding parts, corresponding means the middle one and the middle one, the first one and the first one, are congruent, which means the same. So since B and F are in the middle positions, this B is 99 degrees, this F is also 99 degrees. Now it doesn't really look like it, does it? But they drew it distortedly to make sure that you followed this rule. So if I knew that this is 99 degrees and that's in the middle location, and then F is its buddy, look at this. F has 8y minus 5. So I'm able to solve this problem by just solving this because I knew that it had to have been 99 degrees. And then as I move through this, then you got measure of angle F is congruent to B, definition of congruence. We'll get into all this in a little bit. You know, then I'm just basically solving here. That's all I'm doing. Okay, getting y is 13. If I go back to this statement that I had over here, all I'm basically doing is solving this and take a look that I ended up with y is 13. Now, I'd like you to kind of maybe try to figure out x and then come back to the video and check your work. That should be your result. See if you can do it. Hopefully you did. Check it. Make sure you have it down. I'm moving on. Now you're going to do a similar item. Okay, so give it a try to this one, but before you pause the video to try it, I'm going to give you a suggestion that I find helps. I find it always helps to orient the triangles. So if I have this triangle RSV, this is the order, R to S to V. I like to take this other one and draw it oriented the same way, TVS. So T, it got cut off over here. T is over here, and V is here, and S is here. So what I'm going to do is I'm going to kind of take this triangle and I'm going to kind of rotate it so that it's underneath its buddy. So R goes with T, so I'm going to put the T over here. V goes with S because it's in the second spot, so because S is written up there in the top right, I'm going to put the S in the top right. And then V goes with S and S goes with V. So kind of when you rotate these around, you kind of get this flipped like that. It's very interesting. So now I have them rotated the same way, but you don't have to do this rotating them the same way. It just kind of helps. Let me erase a little bit of this so we can kind of really look at the picture without getting confused. So I know that R and T are in the same location, so I know these angles are the same. So I'll put a little 1 mark there. I also know that when I rotate this one around, S goes on top of V, and then V goes on top of S. So when I rotate it around, I think I have this backwards. The S should be down here, and the V should be up there. Basically, I have this right angle that was here, but in the other picture, it ends up to be down there. So it's hard to draw that like that. I should have probably drawn the right angle like that. And then, S goes on top of V. So this was 78 degrees here, so when I rotate this one around, I'm going to change colors because this is getting tiny. This is 78 degrees. So basically you're finding the corresponding parts. So now when I rotate this around, this guy would be rotated on top of this guy. So, erasing this so you can see it, I would know that 2y minus 1 is equal to 24. Okay, so then I add 1 to both sides. I get 2y equals 25. Divide by 2, you get y equals 12.5. And then to find x is this angle measure out here. This is 78, this is 90. 90 plus 78 is 168. The three angles must total 180 degrees. So to get that other little wedge, I just have to do 180 minus 168. And that would be 12. So this little x degree measure is what 12 degrees is. Okay, that's kind of the trickiest problem that you're going to. Here's one more. I think this is one. This is the last one, so let's kind of just take a look at this. If you want to give it a try, feel free to give it a try. So I've got a lot going on here. The planners in the senior banquet are tied fold paper napkins using the triangle pocket fold so that they can place a small gift in the pocket. Now here's something that I need to write down. NPQ, so N to P to Q. That angle right there is the same as R to S to T. R to S to T. So now I'm going to redraw that red one I just drew. Here, here, here. R, S, T. Then I'm going to redraw the black one here. N to T, to P, sorry, to Q. So let's write this again. N to P to Q. I am going to do some erasing up here so that it's not working for my eraser. All right, well, let's continue on. NPQ is 40. Okay, so if NPQ is 40, this one right here is 40. The question is, what's SRT? So SRT is this one. I wonder if that's the same as this one. I don't think it is, because they said NPQ is the same as RST, this one. So if that was 40, so's that one. I wonder then how I can figure out what this one is. Well, I really wanted to erase this, but I can't, and the reason why I wanted to is because there's right angles here. I don't know if you can see those yet, or they're covered up, but I have right angles here. So, if this is 90, and this is 40, this has to be something, so I have a total of 180, which is a triangle angle sum theorem. So 90 and 40 is 130. And then this, obviously, that SRT, measure of angle SRT, must be equal to, must be 180, so that's got to be 50. Okay, so you got to remember a lot of old stuff along with a lot of this new stuff, but I think the most important thing is kind of knowing that the order is important. Back, yep. Now, there's two things you're going to have to do for an assignment here. Thing number one is you're going to have to fill in this Freyer model. This leads into next lesson. So the first thing I'd like you to do, kind of on your own, is I'd like to fill in these sections. So if I had a word that I said congruent triangles, we talked about congruency, we talked about parts, I would like you to try to make up your own definition of what you think congruent triangles would look like. Then I'd like you to draw a picture of that. Then I'd like you to give me a couple examples of what that would look like, and give me a couple non-examples, and be specific in these pieces. Ideally, after you make this, I'd like you to try it on your own, then I'd like you to compare with someone else. So we'll talk about that a little bit. And then lastly, your homework is this 4-3 worksheet. Now, just a comment on that, be a couple parts like question 5. This is question 5 from the worksheet. So here's the entire worksheet that you're going to be getting. So when you get to question 5, it says proof. We're not going to talk about the proofs today, but what I'd like you to do is, with these problems, is I'd like you to mark up your picture from the given. That's all you need to do. So using 1 marks and 2 marks and 3 marks like I did in the pictures, when you get to those proof statements, I would just like you to mark up the picture, and that's all for today. For the proofs, everything else, you're going to have to figure out X and Y. Thanks for listening, and have a good day.